Hello everyone, welcome to Gyanti, a channel where you get to know everything about data science. Okay, so far we have covered 7 different sessions on named entity recognition and relation extraction. We started by understanding the NER and relation extraction. Then we went about doing the labeling through the Label Studio. Then we had the custom NER done through Spacey transformers, and the transformers. And in the previous session, last 2 sessions, in fact, we learned a lot about relation extraction using Repo, right? In this session, we intend to be discussing another model, state-of-the-art model for relation extraction, that is Rebel. Okay, so Rebel essentially stands for Relation Extraction by End-to-End Language Generation. It uses autoregressive sequence-to-sequence model. So what are autoregressive sequence-to-sequence models? Think of them as the language generation models like the T5 or the BART and so on, right? Where you would be having the encoder component and also the decoder component. If we see how Ripple performs on the different datasets, you'll find it really does a very good job on multiple different types of the datasets. Like on the adverse drug events, it's scoring a rank of 3, on Connell 04 again a rank of 3 or 1, and Doctorate is rank of 2, 1, and there are several other datasets where it does really very well. So that's why I thought that it will be useful to discuss about Rebel as one of the frameworks for extracting the relations from the text. Okay, so what's the key mechanism, how it operates? So like I stated, it uses autoregressive sequence-to-sequence models. These are the type of the sequence-to-sequence model which have a series of the components. An encoder which processes a sequence of the input data and a decoder which produces a sequence of the output data. In case of Rebel, it uses the BART large as the base model, right? It expresses triplets as sequence of tokens such that we can retrieve the original relations and minimize the number of the tokens to be generated so as to make the coding more efficient. Okay, this step essentially is called the triplet linearization process or a step, and we'll know a little bit more about it. In fact, for this purposes, it uses a set of the new tokens as markers to achieve the triplet linearization. So you'll find that less than triplet greater than mark. This particular mark it uses for denoting the start of a new triplet with a new head entity, followed by the surface form of the entity in the input text. Surface form meaning the entire text which is under the subject entity, the entire text part of the entire text part of the subject entity. The less than sub subj greater than marks the end of the head entity and the start of the tail entity surface form, right? So if there are a single subject with the multiple different objects, then there will be a single subj related entity or marker, and then it will be followed with all the other obj related entity. We'll see the implementation of this in the next slide. The obj marks the end of the tail entity and the start of the relation between the head and tail entity in its surface form. Fine. Okay, let's see one of the examples from the paper itself. So it says, "This Must Be the Place" is a song by new wave band Talking Heads. So, uh, so the name of the song is "This Must Be the Place," and and the genre of the band is new wave, and the band name is Talking Heads. Okay, and it was released in November 1983 as the second single from its fifth album, Speaking in Tongues. So if we see the various triplets that get extracted from this text, it's as below. This must be the place. That's the subject, and performer is the relation, and talking heads is the object, right? So this must be the place, and the performer, the name of the band, is essentially the talking heads. Now, talking heads is of the genre new wave, right? So that's what is here, the second triplet. Then it also says this must be the place, that's the subject, and is part of speaking in tongues. So the name of the album, in fact, is Speaking in the Tongues, and it's the part of this album, right? The song is the part of this album. So that's why we have this as the subject, relation is part of, and object is speaking in tongues. Now, speaking in tongues, is again an album, which is, and the performer for this album is Talking Heads. Okay, the band name is Talking Heads. Okay, so we have to essentially extract all these relations, and the way Rebel actually generates the triplet linearization is like here. So we have the start of the triplet here. This must be this place. So like we saw in the previous slide, this is the subject. Talking heads is the object, and performer is the relations expressed between the subject and the object. Now, the second, again, we see the second subject here, SUBZ. Now, this is essentially the marker for this must be the place, the first one itself, right? Because now we are trying to express this third relationship, which you see uh, in the left hand side bottom box, right? So where we have this must be the place as the subject, part of is the relation, and we speaking in tongues is the object. So here our subject continues to be this must be the place, and object is speaking in tongues, and part of is the relation expressed between the subject and object. The second triplet is talking heads. Now that is the subject we have, and new wave is essentially the object, and genre is essentially the relationship between the subject and object. The third triplet that we have is speaking in tongues, and which is the subject, talking heads is the object, and performer is the relation expressed between subject and the object. So this way is how the triplet linearization is achieved in case of Rebel. And this makes sure that the number of the tokens generated in the process is most optimal. Okay, so you might want to pause a bit here and give it another thought as to how this triplet was essentially obtained. Just keep in mind that there are three different triplets or three different or unique subjects here. This must be the place, talking heads, and speaking in tongues. Okay, these are the only three different or unique subjects, and they are to be marked with the different objects and relationships. That's what is getting done in the right hand side box. Okay, so then moving on, the mechanics. Let's talk about the mechanics and demo. So we'll be essentially referring to these two GitHub repo, Babelscape Rebel and joint here, Rebel for the code purposes, and then joint here for some of the data that you might be wanting to experiment like the NYT dataset and so on. Okay, so now let's get into the mechanics part of it. Okay, so here we are on the Babelscape Rebel this GitHub repo. So this is how you will find the different directories: conf, data, datasets, docs, experiments, src, and so on. They also have got the code for demo.py. We also have the requirements.txt, setup.sh, and the spacey component.py. Okay, so if we see the repo structure, it has the conf directory, which contains the Hydra config files for data, model, and train. And then it also talks about the model as a repository where model files are to be stored. And src contains the various other Python files uh, containing, say, for example, pl underscore data underscore modules dot py. It has the lightning data module. Pl underscore modules dot py has the lightning module, and so on. And train dot py is the main script for the training the network, and so on. Okay, so what I have done is I have downloaded the repo and got my ID set. So this is how the things look like on my ID. So I have uh, the model directory, and I'm calling it as Babel Escape. The reason is that several places authors have in fact used this particular part, Babel Escape slash or stroke rather, and we have Rebel Large. Okay, so that's what authors have used at several places. So I'm calling it as Babelscape, and then so in this essentially has the model. So you have got the config.json, vocab.json, pytorch underscore model.bin. Then conf, like we discussed, it has got the Hydra files, and essentially it has the conf or config for data. So depending upon whatever kind of the data that you use, say adverse event or kernel, or if it is the default data, then default underscore data YAML. So this is how it looks, where I have made certain changes here. So in the default version, you'll find the num workers to be 6, right? I have made it to be 1 because of my current hardware issues, right? And the dataset name, again, I have changed the paths here. So depending upon how your directories and how your local environment is set, you may want to please change the path accordingly. Similarly, if instead you have your data available in the NYT underscore data format, then you may want to change the paths and so on here. Right? The default one that you'll find is home, Martinage, Ripple, datasets, and so on. So we need to change this. Okay, so that's on the data side config. Model side of the config, default underscore model, nothing much to be done. Here they use, like the paper stated, they use BART large. So that's what is here as the base model. On the train side, default underscore train. Again, I have made a lot of changes here just to make it work. So I'm using a batch size of 1 instead of 4. For eval, I'm using again a batch size of 1 instead of 8, which is the default one, right? So depending upon your hardware, kindly make the changes here, right? So that's on the train side, right? And on the data now, this particular folder essentially contains another subfolder called Rebel. I have added NYT subfolder here, and I have kept the 3 different data. which are dev, test, and train. This data is what you can get from uh, join TR. So you can go to their data sets, and from here you can get the data, right? NYT hyphen multi data. Okay, so in just in case you want to see the performance of it on the NYT dataset, the it also comes with a sample .json, and which is for the default version of their model. If we see this data, this is how it looks like. It's been trained on this kind of a data set, and they use an annotation tool called Crocodile. Um, so if you see, it has got these different elements. So we have doc ID, and then the title, URI, and then we have the text. And for the text, we have got the entities. Now the entities, they again have got the URI, unique resource identification. I believe that's the full form of URI, and then it has got the boundaries and the surface form. What we were discussing earlier in this slide has got a text here, academic journal, and who was the annotator. So I think that's the ME for me. So that's how this data is represented. They have provided this sample file which contains some thousand of the records here. And essentially, you'll find that their demo, the Streamlit demo that they have provided, runs on this sample.json. If you need to train it on the original data, then again, you please download it from this repo. So you can download the model and the data site files from here, sf.io. It would look like this. So we need to download Rebel both the datasets. These are some 1.4 GB file. So we need to download both of them. Okay, so that was about the data. Then the data sets, it contains the Python scripts essentially for the pre-processing purposes. So when we go to nyt underscore type.py, you'll find the mappings. So originally NYT represents the subject, object, and relationships in this form. There is a corresponding mapping which has been provided in the document, and then the rest of the codes are there to get it in the requisite format, right, or do the necessary pre-processing. Then we have the placeholders for experiment. We have the outputs, which essentially contains the Hydra files. So you'll find .hydra and the config.yaml, and then hydra.yaml overrides. So these are the final configs that get applied. Rebel underscore data, this is the ntest.jsnl, train.jsnl, val.jsnl. So these are the files on which the model has been trained. And like I stated, I downloaded it from OSF, right? And so that's about it. And then the SRC, this contains several of these Python files for generating the samples, model saving, modeling part, and so on. Now, since they have been put under SRCs and my root directory is rebel hyphen main, hence at several places I have to actually change the code when say importing a particular module from these Python scripts. So I essentially would have to do src dot generate underscore samples, right, to import a particular function from here. So which I have made the necessary changes at several places in my code. Like here, from src dot generate samples, import generate text samples callback. Okay, so I have added src dot just to make sure that it works as per my current setup. Okay, so then we have got so everything set with this. Uh, the repo actually provides some bit of information on how to go about it. So they have provided the code for the very basic experimentation purposes. So we'll try that. So for that, I have created a file called main.py and essentially copy pasted this entire portion to here. Okay, so we'll try this. It says from transformers import pipeline. So we do that, then triplet underscore extractor pipeline. Text to text generation model is Babel scale, Rebel large, and again tokenizer is Rebel large. So I have just initiated that, and it takes a couple of seconds. So we have this pipeline ready, all right, and the extracted text here. My text is this: Punta Cana is a resort town in the municipality of Higai. Sorry for the bad pronunciation. Okay, so this one, okay, so we get the extracted text here. So I just ran it and we can print it as well. So we get the extracted text or a triplet here. Punta Cana is the subject and La Alta Gracia province is the object. Located in the is the relation. Now to get it in the better form, it says it's a function to pass the generated text and the extracted triplets. So we'll run this and okay, so this one we get it as head is Punta Cana, type is located in the tail is La Altagracia province. Okay, now this one is clear. Now they also have provided the means to add it to the spacey pipeline, right? So that's what is here. So we can take that portion of the code. So we have we need to do import specie. It's not there in requirements.txt. So you will have to separately install specie. And so please make sure that you do a specie 3.x and we just ran a specie underscore component NLP will load the Encore WebSM model and I have already added the pipe here, so I do not need to add it the second time. But if you are trying it for the first time, please make sure that you have added this pipe. Okay, so essentially this one. And my input sentence is there. And I will first create the specie document and then I will create a doc list and then get the relationships and the corresponding value out from here. Okay, so essentially, so here we'll run this. So talk.rel will be getting something like this. Uh, Relations located administration. So this is essentially the text which we should be getting when we have run the spacey pipeline. It's not coming for me, but then this is what we should be getting. Okay, so which gives you the span here, and then it tells you the relations and the header span and the tail span is given there. Okay, so that was about the main.py and how do we sort of add it to the spacing. Next thing is how do we train and replicate whatever we have it on the rebel underscore large. For that, we need to take the default data set and we just need to run this train and train.py. So it starts with this and uh, it will be importing all the libraries and so on. And it will be seeding a global value. In this case, it is 42. It says special tokens have been added in the vocabulary, and then it will go about performing the rest of the task as well. Okay. So some of the tasks, sorry, here like it will start reading the GPU whether it's available or not, and then it will also do some validations, and then it will train the model. Okay, so maybe you can give it a try once you have done the complete setup on your local. And one last thing which I quickly wanted to talk about is is essentially the demo, uh, the demo.py. Okay, so we'll see this. The demo.py, we have here the Streamlit demo related code which they have made available. So this is the version of the code. What I have done is I'm running it separately on my through my command prompt. Okay, and now this is also available. So I'll go to our demo Streamlit. So this is where we have the code, and it what it does here is maybe I'll make it a little larger. So what it does here is it asks you for the dataset ID. I can set it anything between 0 to 1000. It essentially will pick the text from the sample.json JSON-L that we saw earlier, right? So similarly, and then it asks for some of the other params like length penalty, num paints, and return sequences, etc. In the if the current input text is Chalopek Hill, is the ice-covered hill rising to 946 meter in the North foothills of Detroit Plateau on Trinity Peninsula in Graham Land, Antarctica. And these are the outputs that's been provided. So we have something called the silver output, and here the triplet is essentially Trinity Peninsula is the subject, Graham Land is the object, part of is the relationship, and again uh, Trinity Peninsula is the subject, right? And that's why we have the subject here. And Antarctica is the object, and Antarctica is essentially the continent. So Antarctica continent has Trinity Peninsula in it. Okay, so that's what this relationship suggests. Similarly, we have the second triplet here, which is Graham Land subject, Antarctica is the object, and continent is the relationship type. So that's what is presented here in a cleaner way, and then it also gives you the triplets for each of the sentences, sentence 0, sentence 1, and likewise. Let's try for something else as well. So maybe I will pick something, say randomly, I will pick the eighth text from the sample. So it says the input text is essentially it surfaced in the first half of the 14th century at St. Rumbold's Cathedral in city of Mechelen. Pardon me for my bad pronunciation anywhere, right? And it says the silver output looks like this. St. Rumbold's Cathedral is the subject. Mechelen is the object located in the administrative territorial entity. Okay. So it's the located in the administrative territorial is the entity. Okay, so that's what is the relation which has been predicted here. Okay, sounds great. If I want to give my own input, then we can give it from here, right? So, say for example, if I say um India Gate is in New Delhi, India. Say for example, if I want to give it this text, press enter. India Gate is in New Delhi, India. Okay, so let's see what it does. So it says the prediction text is India Gate is the subject and New Delhi is the object located in the administrative perfect. Okay, and it is the subject. India Gate is the subject. India is the object and country, which is again fine. Triplet. The another one is New Delhi is the subject, India is the object, and country is the relationship. Perfect. I think it got it right here. So that's how it works. We can play with it, and we can train in Ripple model specifically for our purposes and get the different relationship extracts as needed for our requirements or for our purposes, right? Hope you like this video. Stay tuned. There are a lot more things to come up. And going forward, we'll embark onto a new journey. We'll pick up one another thread, one another important topic in the text mining and image mining or image processing, and we'll delve deep into it. So, idea is to get into the mechanics, get the understanding of the things, and then it should trigger some thought process in you, and you might become a little more comfortable in doing the day-to-day stuff, right? At your workplace or even otherwise. So thank you. Thanks for your time.